The recording is started, so I don't forget this time. Give everybody a minute or two to join. Here they come. Anybody have any big plans for the weekend?
I will be at a wedding, if that is a big plan.
Out of town or in town?
It's up in like Ventura area, so a little bit of both.
Gotcha. Beautiful area.
Should be fun. Good excuse to get up there.
Yeah, a little bit of wine country up there. Some fun stuff. Did you go to SLO?
Yeah, I went to SLO.
Okay. Nice campus up there.
Oh my gosh, SLO is the best. I miss it. I went up there probably 6 months ago, and you forget how nice it is.
That's what's the name of the college?
Cal Poly.
Cal Poly, right? Okay, so yeah, very nice school. What was your major there?
But it was a mouthful. So my undergrad major was industrial technology and packaging, which is somewhat of like a hybrid business engineering degree, kind of like supply chain manufacturing focused. And then I got my master's in business analytics.
Okay, cool. A lot of my family worked for a company in Minneapolis that did packaging. So cardboard is very near and dear to my heart.
Oh, I learned all about the corrugated board, Tom. Let me tell you.
Hey, corrugated fed my family for 25 years. So the origins of the company were kind of fun too, because they started like in the middle of the Depression, the Great Depression, 1930-ish, just devastating economy. Guy starts the company. What he did was he would go around to all the stores in the Twin Cities and get their thrown away cardboard boxes and recondition cardboard boxes and sell them again. And that launched the company. And, now they're like $1 billion company 100 years later. So wow. When people are all downbeat and the economy's crap and I can't do anything, it's bad, everything's bad. It's like, I always think about that. Here's a guy who just went door to door gathering up cardboard boxes and cleaning them up and reselling them for an extra penny or two and putting food on the table for his family, but it ended up launching a huge business.
That's a great story.
Yeah, and I mean, to this day, it's still a family-run company, and they get all kinds of awards for being a great place to work and stuff like that. So
nice. It was should have gone the packaging route.
Yeah, could be. Not as exciting as data science, maybe in some ways, but one thing I have to say is just personally looking at my evolution of packaging. I just got the new Apple Watch, and there's like not everything about it, all the cardboard, everything folds up in such a way that no adhesives are needed. Just the evolution of reducing the amount of material, reducing the number of different materials, but still having this super premium packaging. It's really pretty impressive, I have to say.
Yeah, we're like approaching the limit now too. You can only get so much better with boxes, yeah.
I keep thinking that, but like I said, this watch thing, the way it was packaged was really a little bit different. Anyway, let's see. Well, why don't everybody can see my screen? Yes? Everybody's good?
Good to go.
All right. I guess we better get started. I got a fair amount of stuff to go, and let's just talk a little bit about the rhythm of the class. So next week, we're going to take a break. India, it's a big holiday on Thursday of next week. It's Gandhi's birthday, if I understand correctly. Subham, is that correct? Thumbs up. Do I have that right?
Yes.
Yes. Subham has his camera on, so he's the only. I was looking for a thumbs up from Subham to make sure that I have the date right. And I think Friday, I suspect if India is anything like America, a lot of people will be taking Friday off as well. So class-wise, since most of our class members are in India, we're going to take Friday off. I'm going to be going out on medical leave as of next Thursday. I suspect that I won't quite be ready to teach a class by the following Friday. So Parit is going to teach. He has been working his way through what is considered to be the Bible of retail sales forecasting by a guy named Heinemann. And he's going to present a summary of what he's learned from that book so that we can bring everybody up to speed on what he's been finding out, some new nuances on forecasting, some of which is going to be informing our next version of the stats forecast. So we thought it was important to not just talk about AI, but also forecasting in general. So that's kind of what we're going to be doing. Today we're going to start on vector databases and RAG as our we're going to get some background going. I'll see how far I can get through the material. I've got a sample notebook. Worst case, if I can't get through all the coding, I'll put it in the Git, and the homework will just be to work through the notebook basically and understand what's going on. So recapping from last week, remember we batched all of our LLM calls into one sort of monolithic call. We then used the response format parameter and some JSON templates to format the output coming back, which again, I think is, if we want to treat LLMs as essentially a function call, we have to be certain of the format of the output coming back. We can't have it just blurt out a bunch of text. We need it formatted so we can deal with it as data. And then in the homework, we expanded to iterating over multiple tickets, returning the type category, and even generating an answer. So that was, if we look at the homework maybe a little bit, let me just pop that up. I don't want to spend a huge amount of time on it because we've got lots more to cover today before we go out on fall break. So basically, I just want to show you what I did and a couple of comments. My number one comment is the data is pretty bad in the spreadsheet. In my opinion, the assignments that were made by humans in this case were not very good. And so I guess what I'm kind of saying is if you did the comparison work, you'll find that the LLM assigned things and the human, it's in pretty serious disagreement with what the human team did. So I don't know that there's a right answer, and I'm not sure we care that much. It is a good step to QA it, but actually I'm starting to feel like the LLM is doing a better job in general. So the first homework was, process the model, try some different models, etc. I went back and I kind of redid the prompt. I tried to tune the prompt to get some better results, even using some examples, some,
Hey, Tom.
Yes. Sorry, I'm not sharing the screen, am I?
Yeah, so we're still seeing the slideshow.
That's okay. I haven't shown anything important yet, but good point. Here we go. Sorry about that. So I rewrote the prompt a couple of times to try to get it to be more like what the humans did. And the best I could get was about 70% accuracy. So my suspicion is that the assignments are not very good, as I said. So anyway, I ended up with I added some confidence intervals or confidence stuff as well. So the assignments, priority, business type, incident, or the type of incident, etc. As I worked my way through, the matches were just not not great. Business type was around 70%. I could change the prompt a lot and get different things would get better and other things would get worse. So part of it is, I think, to get things better in some areas, the prompt grew so large and it actually became somewhat contradictory. I think to get any better, probably would have to actually break the prompt apart and go back and do each column individually, because the prompt is just getting too big and crazy. So I did a detailed analysis and looking at, the kinds of errors we were getting. And really, like I said, I think the problem is the original categorizations were just so loose and not very accurate that I would say in this case, what we would probably do is do a pilot project, have the LLM assign things, and then have the humans who are receiving in the queue sort of mark them as a mistake or not, and then keep track of that. That would probably be a better use of our time than trying to judge against what humans did previously, because we don't know what the error rate was. So without knowing the error rate of the original assignments, comparing ourselves to it is probably not going to work very well. This is a problem that would probably happen with things like clustering. If humans were kind of putting clusters together, they would make a lot of mistakes, and the LLM might have some errors in it too. So comparing one error-filled thing with something with unknown amounts of error probably will not get you too far. Anyway, so the last one was to generate a response, which was pretty straightforward. Just feed it the subject, feed it all the same data that we just generated, and then generate a response. Answer this. And most of the responses were kind of like, hey, thanks for telling us. We're going to route this to our team. Send us any more details, and we'll get back to you in 22 days or whatever. Kind of the very standard generic responses. So what we want to, I did it for all of the things in the sample data set. So, you can see, thank you for notifying us. Thank you for reaching out. I've noted your interest, blah, blah, blah. It's all very, very generic. So what we want to do this week is start to go down the process of generating better responses. And how can we do that? So let me go back to the slide show. So how can we do that? So our problem is we want to automatically respond to a ticket with relevant and helpful information, and hopefully we can answer some percentage of tickets automatically. Again, we're looking to relieve the burden on our overtaxed IT team. So if there's a simple question and the LLM can handle it with confidence, we want the LLM to handle it with confidence and respond to it. Now, LLMs in general have been trained on trillions of words of text on the internet, and that's all great. And they do a pretty good job of responding generically to a problem. And they could probably answer some of the questions, but again, are they going to be trained on the Hewlett-Packard 2800 DeskJet printer setup and what the error codes mean? Maybe, or maybe they'll just make stuff up and we won't be sure of the answer. So we have 3 ways that we can give an LLM more knowledge. And that would be, we can retrain it from scratch with a data set that contains the knowledge we want to be in there. So again, most LLMs are trained very generically with lots of text from the internet. Keep in mind, there's, if it's scraping Reddit, there's going to be lots of good answers there, but there's also going to be lots of bad answers. During training, the LLM really doesn't know which is good and which is bad. But hopefully the good answers overrule the bad answers, but we can't be sure of that. So training is one way to do that, where we could craft a training set of billions of pieces of text from the internet But then for all of our IT questions, we could also really add a lot of specific knowledge about our IT environment, et cetera. And then the LLM would be capable of answering that. But it's sort of like you studying for a test, right? You've got all this knowledge, and then you're going to study for this test that you're having on Friday. You're going to cram that information in. It's going to get intermixed with a lot of other things. You're going to forget some things, etc. So we can add all this knowledge, but it does get a bit diluted, and it's a big process to do this training. So we can also do fine tuning, which for those of my closer team, we did a class specifically on fine tuning a few months ago, and that is a little bit easier. And then finally, we have a thing called RAG. And so let me dive into a little more detail here. So training from scratch, we're basically going to create a whole new training body of text, and we're going to make sure that the stuff that we need to answer our IT questions is in there, and in there a lot, and it gets focused on. So it's possible that GPT-5 was trained on the HP 2800 DeskJet manual, but it wasn't emphasized. So just like you learning all the stuff throughout your life, there's bits and pieces in there that you have difficulty accessing. So you may have learned something at one point. You may have read the HP 2800 manual yourself, but that doesn't mean that 10 years later you can remember what error code 62 means when it's flashing on there. It's in there somewhere. Same with the LLM. There's billions of parameters in there. It's in there somewhere, but we're not always confident that we can pull out such a precise answer. So I want you to keep in mind that LLMs, their superpower is language manipulation, not necessarily knowledge. And that the one nice thing is that even small models are really good at language manipulation. The smaller the model, and remember our Conehead example from the first class, small model may not have the knowledge, but it can still talk and it can still manipulate language. So if we give it a little bit of extra stuff, we might be able to take a relatively small model and completely retrain it so that it can talk, but it also is a little bit more focused on our particular domain. The problem is it's very expensive. You need a lot of GPUs. Training is intensely GPU specific. It takes a lot of GPUs. It takes a lot of time. It takes a lot of data setup. Everything about it is expensive and takes time. I mean, the frontier models now are taking thousands of GPUs. The new Blackwell RTX 6000, I believe each one of those is $10,000. Okay, and that's consumer grade. That's a consumer grade graphics card. The commercial grade versions of the same things run about $20,000 to $25,000. Now, maybe if you're Meta and you're ordering 100,000 of it at a time, you might get a small discount. But NVIDIA is selling every one that they can, so I'm not sure they're discounting them too heavily right now. So in order to train a large model, you might need a few thousand of those cards. So you're looking at millions upon millions of dollars of hardware. Then you're also looking at the time, the effort, and the energy to train it. And so to train a large frontier model, you could be looking at $50 to $100 million for a training run. A small model, maybe, $50,000, $100,000. So if we're Vuori, do we really want to train up a model from scratch? Probably not. It's a very expensive proposition. So the next level down is we could take a model that we already have, and we looked at some smaller models, Qwen 4B, some 4 billion models, and that's what we did in our internal training class a few months ago. We took a small model, and what you can do is use a technique called LoRA, And I'm not going to get into all the details, but basically what you're going to do is reach in and add a layer or two of new neurons into the neural network inside of the LLM. And you can train just a few layers to add knowledge. Now, again, it's still not the greatest in terms of adding knowledge. It's still somewhat expensive. It still takes a lot of data. You know, if you could, again, imagine yourself studying for a test. It takes a lot of effort, time and effort to study for this test. You've got to memorize facts and things like that. Compare that maybe to a take-home test where you can refer to all your notes from the class. You can refer to, the books, etc. You can go on the internet and look for answers, whatever. Instead of testing your memory, we're testing your ability to take all this information and actually do something with it. So the goals are a little bit different. So with fine tuning, we're still adding information. And I would argue that the best use of fine tuning is not so much to add pure information and facts, but it's to change behavior. So you can fine tune an LLM to give it kind of a new behavior. Maybe train it on a new language. It already knows how to manipulate language in general. Maybe we want to teach it a new language. So we can give it lots of examples of translating from English to Swahili or something like that, a language that it doesn't know. But it does know the general ideas of language. So I think fine tuning is best used to teach it a new skill or a new behavior rather than new facts. But it can be done that way. I just don't think it's the best way. The third way, the third way is RAG, which I guess I'll talk about in detail in a minute. And I've got that here. So again, training from scratch on a small model might be up to $5 million, take months to do, takes lots of GPUs. Fine tuning, much cheaper, but it still takes a lot of hardware, etc. And we're going to talk about RAG in today's class, retrieval augmented generation. So we're not going to touch the LLM at all. What we're going to do is create a system that provides it with more context in the prompt automatically. So what do I mean by that? Well, if we go back to our example of the HP 2800 DeskJet printer, what if we were able to give it access to the manual, and we build a system that if a user asks a question about the HP 2800 DeskJet printer, what we do is we look at that question, we go to the manual, and we make sure we get the chapters of the manual extracted that are applicable to the user's question, and we give that to the LLM as context along with the question, and we say, answer the question using this information. We're not asking the LLM to produce any knowledge. We're asking it to use the knowledge we give it and create an answer from that. So it's kind of like you with the open book test. As the professor, I'm saying, hey, use these resources and do this thing. And so it's a very different way to do things. And let me just go through some of the benefits here. So from a knowledge management standpoint, as an IT organization, if we bring in a new printer, we can just add that manual to the pile. We don't have to retrain the LLM. We can just add the HP 2850 printer manual to the knowledge base, and now we can answer questions about the HP 2850 printer. We don't have to touch the LLM. We don't have to go through a retraining process. We can just have a database of knowledge, if you will. So it allows instant updates to the knowledge base. We can have continuous improvement in our ability to answer tickets without having to retrain anything. We can have multiple sources of information. We can have internal wikis. We can have vendor documentation. We can have FAQs. We can go out and search the internet for answers and use all of that with RAG and combine it into what I call context that gets just submitted with the prompt. It's very easy, it's straightforward, and we can also have version control. So if we're answering, let's say we're answering questions about Microsoft Office, we could have all of the Excel documentation going back 10 versions. And if somebody in our company is using, Windows Vista with Excel 95, we can have those manuals. It costs us virtually nothing, and they can just say, "Hey, I'm using Excel 95. How do I do X?" And it can go to that documentation. So versioning is a very important thing, and we can do that easily. From an operational standpoint, we have transparency and accountability. So if we ask an LLM, why did you say that? It can kind of answer that question, but not really. With RAG, we can literally say, what paragraph of what page of what document did you get that crazy thought from? So it can literally give you the source, and it can pull up the text that it used to craft its answer. So we can also log all that into an audit trail. So if we're in a regulatory compliance situation, medical, legal, whatever, we can log what sources we use to give an answer. So if a customer were to come back and say, "You told me X, and that was untrue," we can go back to the log and say, "Well, here's the source material we use. It's the HP manual, and we gave you the information from that. And so if you have a problem, it's with HP, not with us." The other thing is, if we decide we need to hand this off to a human, we can give them all the context. We can say, "Hey, we gave the user this information from the manual. They said that this still didn't work. So we've already tried all these steps. You don't have to go through them." We can scale this. The amount of effort it takes to add a new document is trivial. The amount of effort it takes to encode that, et cetera, extremely trivial. We can use smaller LLMs because we really only need the LLM now for its language manipulation capabilities. We do not need it for its knowledge. The vast majority, I think, of LLM capacity is used up by knowledge. So we could use a relatively small LLM, which means we can serve many more customers. And if we're doing a public-facing website that's supposed to answer questions, that will become critical. We don't want to have a giant data center to answer questions when we can run the whole thing on a laptop. Fast time to value. We can bring up a RAG system in days. It's more about provisioning the data and curating the data. The actual structure of the RAG system is practically trivial. It's very stable. The technical risk is low. It's well understood technology. Anybody can do it, I guess. Anybody can make a RAG system. RAG is currently, if you look at Ollama and OpenWeb UI, it's built right in. If you look at ChatGPT and you go to the playground of ChatGPT or AI Studio on Gemini, Google, or Claude, you can actually create a fast RAG system yourself using those front ends. It's already built in. I like to have a little bit more control over things. And since we're building an app, we want to have more control over things. So we're going to build it kind of from scratch. But the technical risk is extremely low. It's well understood. It's just kind of work. The contextual retrieval for IT answers, we can pull out troubleshooting steps, we can access FAQs, we can incorporate all this knowledge that the organization already has easily into this thing. We can even, once we get more sophisticated, we could bring in screenshots, diagrams, configuration file examples, code examples, everything very easily. So I hope I'm doing a good job on selling you on RAG, because I really think it's a great technique that's easy to use. big issue. I'm sure everybody's heard about hallucination problems. We've got many examples in the US of lawyers very unsophisticated lawyers trying to generate legal briefs from LLMs, and the LLMs will make up cases, will cite cases that don't exist, and the lawyers get into big trouble. So when we use RAG, we can tell the LLM, you must answer based on this knowledge. You cannot make up your own answer. And they will respect that in general. The quality tends to be much more consistent because we're using a curated knowledge base. We know that the documents we put in are correct, assuming we go through a curation process. We can do quality control. We can look at the responses. A couple of the RAG system I've built, I've logged every answer. I've allowed the user to give a thumbs up, thumbs down on the answers. We can process that data later and look at the answers that the user gave a thumbs down to and see what was the RAG doing, what happened. We can look for errors. We can do retries. We can even use another LLM to go through all the answers and judge the quality of those. So there's lots of things we can do for quality control. In terms of maintenance, so if we do fine tuning or complete training, we have to retrain the model. And if we're doing fine tuning, there's a situation in fine tuning where if you try to jam too much in, it'll forget other things. So you can actually kind of overwrite the memory, if you will. So you might be adding new information, but you might also be degrading previous information. There's no free lunch here, so you have to be very careful. Training and fine tuning take special knowledge, hardware, capabilities and skills, whereas RAG really doesn't. A/B testing, we can actually tweak parameters and we can do parameter tuning on the retrieval of knowledge and the context creation. And so we have a lot of things we can do to test our RAG that would be very difficult to do using bigger models and trained stuff. Gradual rollout, again, we can put stuff in the RAG database and we can say, when we pull stuff out, if nothing comes out for a question, then we know we don't have the knowledge and we can punt and say, hey, that's not part of my knowledge base yet. Please complain to the IT guys and get this knowledge in there. So we have a lot more fine control over things using this process. And for the long term, it's easy to swap in a new model with RAG. If we get a new model that's has super capabilities, has 50 more languages built in, we can just swap in a model. It really doesn't affect the workflow. We can bring in a new model. We can add knowledge to the database. We can tweak our parameters. The workflow stays the same. We can just keep investing in improving things, and we can do so incrementally. We can look at, it's pretty easy to look at what questions are being asked, what answers are being given. The ones that are I don't know, we can start to gather those up and start to augment our knowledge base with information that'll answer the questions that are going unanswered. Or we can look at the prompt, we can look at the LLM and we can pre-screen things for inappropriate questions. Why are you asking what the nutritional value of a pomegranate is to the IT system? We can start to filter out, crazy questions and stuff like that. If somebody's trying to use our IT system as a personal therapist, we probably don't want that to be happening. So using the knowledge base to kind of be an arbiter of what we can answer and what we can't is also a pretty good idea. And again, we can continue to grow our knowledge base as we add new skills to our IT staff. We can look at the best answers that IT has given to other questions. We can start to incorporate our own answers into the knowledge base. And then the knowledge base can answer them instead of having a human do that from now on. Any questions at this point from anybody? No. If you have a question, raise your, do the hand raise thing, and then when I get to a break, I'll certainly, respond. So let's take a look at what the workflow looks like, and it's basically there's two big chunks. That's foreshadowing. We'll use the word chunk in a little bit. So we have to create the knowledge base, and essentially what the knowledge base is going to be is documents, FAQs, wiki entries, product manuals, internal documentation on how to do stuff, just anything. I mean, eventually it could be videos, images, diagrams, etc. For now, we're going to focus on text because it's a little bit easier. Basically, what we're going to do is take all of that giant pile of knowledge, and we're going to run it through a process where we pre-process the text. And what we do is a process called chunking. So we have a giant document. Let's say we have a manual for some system that's 500 pages long. We even with large context these days, we don't necessarily want to give all of that to the LLM just to answer a simple question. Number one, it raises our cost because if we give it 100,000 tokens and we're being charged per token, if we give it that much information, we're just going to be charged more money. And also, it's very clear from experiments that giving huge amounts of context tends to weaken the answer. It just, if I give you 100,000 words of text and I ask you a question, you're going to have to read that entire 100,000 words of text to understand what's relevant. So what we do is we do chunking. Just as an example, we're going to take that 100,000 word document and we're going to break it into chunks of 500 words, let's say. Now, there's a little bit of a problem here. It's like, well, what if we just break things arbitrarily at 500 words? What if we're in the middle of a thought that's relevant, and then that's sort of broken up into the next chunk, and we kind of have this thought, and then now it's spread across two things. And if we go looking for that later, we really can't get it because it's spread across two things, and it's never a complete thought. So one thing we do in chunking is we have an overlap. So these are parameters, the size of the chunk and how much we overlap. So maybe we'll do in a 500 word chunk, we might overlap by 50 or 100 words. So hopefully we won't be completely cutting off a thought in between the two documents. It'll be in one or the other or both, which is fine. So then we use a thing called an embedding model. And an embedding model, the purpose of the embedding model, it's a trained model. It's kind of like an LLM, but it's very small. And its purpose is to take a chunk and to turn it into a vector. So now, if you understand the LLM process, and each token goes through a similar process in an LLM. So when you enter a text into an LLM, first thing it does is it tokenizes it into individual tokens, which are sort of slightly smaller than a word, but you could think of them as words. And it assigns each of those tokens a vector. So now we're going to go up, and then those vectors go into the neural network, and then the sequence of vectors ends up predicting another vector, which is then turned into a token, which is then turned into a word, which is then displayed to you as the next word in the sequence. So we're going to use a similar process, except instead of each word being turned into a vector, we're going to turn each chunk into a vector. So then those vectors will be our key to the chunk. Okay, so we're going to create a database of our chunks, which are 500 word chunks of text. Each one of those will have a key that's a vector. And that vector is a numeric representation of the general meaning of the chunk. Okay? So we'll go into this in a little bit more detail, but just take it on faith a little bit that we have a process where we train this embedding model. We present it with 500 words. It returns a 368 number vector, or maybe it's 1028, some large number of numbers that represents the meaning of that chunk of words. Okay, so that's the pre-processing step. We create this vector keyed database. Now, in production, the user enters a query. What does a flashing green light on, on the HP 2800 DeskJet printer mean? That now goes through the embedding model, and it gets turned into a vector, just like we did up here, same exact process. And then that gives us a vector that we can then use to search the database. And the way this database works is we're not looking for exact matches. What we're looking for is returning similar documents. And we'll talk a little bit about how that works in a minute. So we say, hey, database, give me the 5 most similar chunks that have this vector as a key. And it can do that, and it will return similar documents. And you can say they have to be this close or not. Just say, give me 5. Though the chunks then become context for our query. We add that to the user query. So we craft a prompt that says, hey, LLM, answer this user query using only these documents. So now we have an automated system that will take the user query, search the vector database for relevant bits of documents, return those. We can craft a prompt out of all of that, give it to the LLM, and then generate an answer. Okay, that's the process. So we'll talk a little bit about embeddings. So again, a text embedding, we can do this at the word level, which is what the LLMs are doing. We can do it at the chunk level, which is what our RAG system will do. But what's cool about this is the embedding model, just like an LLM, has been trained on millions or billions of words in context. So what the interesting thing about that is it learns kind of what things are similar through context. So a pair of words, as an example, sea and ocean are very close in meaning, but they're not always used in the same way in context. So as an example, we say lost at sea, not lost at ocean, but they basically have the same exact meaning. It's just we just don't say it that way. And that's where a lot of the nuance of language comes from, is kind of knowing what word sounds right in what situation. So the embedding models kind of learn this, but they do learn that sea and ocean are close together. Football and soccer, everywhere but the US, are very close in meaning. And I and we are close in meaning, but they're not close to the other things. So if we kind of look at a little bit more of a graphical representation, we got a 7-dimensional vector representation here. So cat might look like this and kitten might look like this. And you can see kind of from the numbers, they're very close. But dog is further away and house is really far away. So if we were to compress this down to 2-dimensionality, we would see something like this. Cat and kitten are very close together. Houses are way apart. Dog is closer to cat and kitten than to house, but it's pretty far away. Another example that's kind of cool is if we look at man, woman, king, queen, we start looking at this stuff. We look at this embedding, and we can start to do some math on the vectors. So man and woman they're both humans. They're apart because of, let's say, this is gender. Maybe this axis is gender. they're shifted in on the gender axis. And we can do things like analogies using math. It's kind of crazy. We could say, if you remember, maybe your college entrance exams or whatever, man is to woman as king is to blank. Well, what we could do is if you see this difference, that's a vector too. So we could actually say the difference between a man and a woman is represented by this vector. So we can take that vector, add it to the vector for king, and we should get very close to the vector for queen mathematically. I mean, I'm not talking about this is just in general. I mean, literally mathematically, we could add these together and we could find out that the difference between king and something is queen based on the difference between man and woman. It's kind of cool. So we have this space now. And again, with our model, it's probably a very high dimensionality vector. We're talking about minimal, the smallest one I've seen is 368 numbers in a vector. So 368 dimensional space is what we're talking about. And that's a small embedding model. So all of these numbers represent some meaning. So in a small situation, we can actually sort of derive that maybe this first one represents whether it's a living being or not. Is it a feline? Is it a human? So for kitten, we say, no, it's negative, or very close to zero. Gender, is it royalty? So down here, king and queen, they score high on royalty and low on feline. Kind of makes sense. Is it a verb? Is it a plural? These are attributes that we could discover and are being discovered automatically through the embedding training process. It's very unlikely we're going to be able to look at an embedding model and find these definitive of answers, but they're in there somewhere. And some people have done some really cool high dimensionality visualizations that can show you this stuff. So let's switch over to code, and I'll remember to switch my screen this time. And we'll go through a code example, and that'll kind of wrap up for today. And I'll let you guys, kind of look at it on your own. So let me look. Pull up our RAG notebook. Okay, so we got a simple RAG. I've got some instructions in here for how to make sure you've got it set up. So we've got some new components that we're going to be using. We've got a Python library called PyPDF. It's going to extract text from a PDF. So we can give this a PDF and it'll pull it out and it'll chunk it with overlap, as we just discussed. We have an embedding model. We're going to use a library called Sentence Transformers and an embedding model called All Mini LM L6V2. There's lots of embedding models. This one happens to be very small and very fast, so it's good for goofing around with. And we can just download it on the fly, basically. Clear all the outputs. And then we're going to use a vector database. We're going to use the one called ChromaDB, and I think some of our team have already used this. This allows us to create the vectors and store them with their chunks. And it's going to use a thing called cosine similarity search. So I don't know, if you go back to your linear algebra classes, you may remember that the angle between two vectors, the cosine of the angle between two vectors is very easy to compute. And that turns out, the cosine of the angle between the vectors turns out to be a very, very good measure of the similarity between the vectors. So it's a very easy thing to do, to search for vector similarity using a cosine search. So we'll use that. And then we'll use an LLM to actually respond to everything with the context. So again, we'll just use LM Studio for me. You can use Grok, you can use whatever. We've already learned those techniques. So we're going to use a chunk size of 500. Works pretty well as a starting point for documents. You can adjust that up or down and test what works better for your particular documents. We're going to use a 10% overlap. I think I've actually modified this to returning. Top K is a parameter we can set that how many chunks do we want returned. We can set a temperature just like we do for any LLM. You know, we're gonna do the embedding in this, etc. So I've got a few things you can look at if things don't work right. So we've got a little bit of an installation. I've got all of these already installed, so you're going to see that as already satisfied. Then we're going to load some libraries. Most of these are things we've seen before, but you've got sentence transformers, which will be the thing that does our embedding for us. We've got ChromaDB, which is our vector database. We've got Pi to PDF or Pi PDF, which will actually read our PDF for us. So then we've got some configuration things. I've actually set the temperature down to 0.2. I think that's a little bit better. We're going to use the 20 billion model. You can use whatever you want to try. I've got a PDF here, which I'll show you in a second. It is an academic paper, which is, again, I think the Nobel Prize winner, if they ever give it for AI, which kicked off the LLM, sort of revolution. Okay, so again, we've got our libraries loaded. We've got our parameters set. So we read in our Hugging Face token from our environment variables, got all that. So here we're going to sort of set things up. I'll walk through, I want to make sure it runs first. I'll walk through everything. So it's loading our embedding model and it's initializing our database. The first time you run this will take a while because it actually has to download the model from Hugging Face. I've already done that. Once you've done that, it puts it in a cache, so it doesn't have to do it again. So everything looks like it's, let's see, it's initializing ChromaDB, etc. So let me just walk through this. Sure what, I think it's loading some stuff over here. So we've got the final message, LM Studio is connected and ready. So let's look at the code real quick. So we're setting up our embedder is using sentence transformer, downloading the embedding model that we set in the parameters. We set up our database. This is all it takes to set up the vector database. There's other parameters, but we're going to keep it super simple, and we're going to persist it. And if you look over here, you'll see this ChromaDB, and inside there are some magical numbers. That's our actual database, and it's got some stuff inside it, a pickle, etc., some parameters and so on. So that's where our chunks are going to be stored right there. We're going to create a collection called PDF documents. So we can actually, within the database, we can have multiple collections. We can have PDF documents, we can have FAQs, we can have web scrapings, whatever, and we can kind of keep them organized separately. Then we're going to open up our client LLM. So you've seen this about 25 times already, so there shouldn't be anything very new there. We're going to ask the LLM to prove that we're connected. So we just send it a message saying, say connected. We're going to look at the answer and we respond, it's connected and ready. So that's our basic setup. Now, we're going to process the documents. So we've got a couple of routines here. Extract the text from the PDF. We use that PDF reader. Very simple. It's just going to read the PDF and tell us how many pages we've got and how many characters and so on. And then we have a create chunks. And we've got a very simple, very, very simple thing where we're just going to start at the beginning of the document. We're going to take 500 characters at a time, and we're going to create a chunk. And then we're going to embed the chunks by giving each chunk to the embedder, and each chunk submitted to the embedder will create a vector we're going to call embeddings, and we're going to save those away in the vector database. So those are our functions. Then we're going to load and process a PDF. Here's our routines. So we've got basically using those things we just did. We're going to process, it's going to process this document. It extracted 39,487 characters. It created 88 chunks. Remember, each chunk is 500 characters, but there's a roughly 10% overlap. So it batched those up into 3 batches. It generated the embeddings. It stored it in the vector database, and we're all set. So there's 88 chunks now, each of which is 500 characters, each of which has a vector key. That's what all this stuff does. Very straightforward. Now we have some query functions. Here's how we search for a similar chunk. So we have a query. What it's going to do is it's going to embed the query, just like we embedded each chunk. And then it's going to search for that and return the search document. And it'll return that cosine similarity we're interpreting as a distance. So it's going to return the distances of each chunk so that we can kind of report on that. Then we're going to wrap all that stuff up into a prompt and send it to the LLM. And then we're going to use that to ask a question wrapped with the content that we pulled from our vector database. Okay? So pretty straightforward. Those are just basic library functions we just created. Now, finally, we can ask a question. So remember, our paper is about the attention mechanism in LLMs. So we'll start with explain what is attention, explain it for a business user. So here's an example where we're using the strengths of RAG plus the strengths of the LLM. The strength of RAG is it's only going to use the document to answer this question. It's not going to make up an answer from its own memory. But this part, explain it for a business user, that's an LLM language manipulation request. Okay? We could also say translate it into Hindi, and the LLM would take over at that point. So think about breaking things up into 2 pieces. There's the knowledge piece that comes from RAG, and then there's the language manipulation piece that comes from the LLM. So if we run this, we get an error. Great. Let's see. Ask question is not defined. Oh, I'm sorry. I never ran this cell. Sorry about that. So query functions are ready. Now we can run. So what is attention? Explain it for a business user. So the first thing you're going to see are the chunks that were retrieved. So here's chunk 1. You can see it kind of starts in the middle of a sentence and it ends in the middle of a sentence, but it gives us the similarity. The score is 0.48, so it's kind of medium similarity. Self-attention can yield interpretable models. We inspect attention. You can see the word attention is used a lot in this. The second chunk, a little bit less similarity, but there are the words. In fact, there's a whole section called attention. Then we have one that's kind of formatted weirdly. It's probably the very last piece of the thing because it's padded. So we have end of sequence and a bunch of padding. And it's a figure. There's a description. Here's a figure description, an example of the attention mechanism. Here's another chunk, the 4th chunk. Again, lots of attention. The 5th chunk, you can see as we go through the similarities dropping a little bit. Then it generates the answer and it returns the answer. So attention is a way for the model to look back at different parts of a sentence or sequence when it is trying to understand or generate text. Think of it as a smart spotlight that highlights the most relevant words for each word being processed by the LLM. How it works, For every word, the model creates a query vector. Then it compares this vector to all the other words, and then it assigns a weight to each comparison. So what attention does is it creates a context. And why are we doing that? If you think about language, an example I use is in a sentence, the word interest could have a lot of different meanings. It could mean I am interested in that subject, or when I put money in the bank, it earns interest. Two completely different meanings of the word interest, and the only way we would know is from the words around it. So the attention mechanism in an LLM supplies the LLM with vectors that explain the context of a particular word, okay? And so what we're doing here is trying to explain to our business user what that means. That's what we asked it to do. It took the 5 chunks that we retrieved from the vector database and returned this nice explanation at a business user level. So I included a little utility function here that returns, it looks at the database and it'll tell you how many chunks are in it. It'll tell you how many dimensions are in each vector, 384. That's a very small vector for this sort of thing, but probably good enough for what we're doing. And then it tells us where everything is stored. So that's what I wanted to cover today. I wanted to give you an introduction to RAG. I wanted to give you some code you could play with. The homework assignment is just get that code running. Ask your own questions, upload your own document. Evan, I know you've been working on some RAG stuff of your own, so maybe try some different documents here. Think about documents that may not be on the internet. I know, Evan, you've got source documents that are probably not on the internet, so you're sure that you're not getting knowledge leaking over. Try to find some things that are either old or maybe in a different language or something underrepresented on the internet, an FAQ, something like that probably wasn't scraped during training. And just you can use this to talk to that document. Upload your favorite book and ask questions of the book. Rakesh, you're a big Lord of the Rings fan, I assume. So you could upload all the Lord of the Rings books and ask, what happened to Frodo, stuff like that, and it'll do a good job. You can see how simple. This is just a couple of cells. I think you'll go through it. You'll see it's pretty easy to understand. And just play. If you haven't done RAG before, play around. I think it's kind of magical that you can give the LLM new knowledge. It's never seen it before, but the language manipulation functions really make it work very well. So I'll hang around for a couple minutes if anybody has any questions. But again, I'll be off for a couple weeks. No class next week. Parit will be teaching the week after. Excuse me. Always, if you have any questions, remember, check out the class Discord. Sign up for that. Ask questions there. Ask questions in Teams. I'll do my best to monitor things while I'm out and try to answer, but talk amongst yourselves. Help each other out. If you don't understand something, ask everybody else. So with that, class is over. If you have a question, please feel free to ask. Otherwise, have a good weekend, everybody, and we'll see you in a couple weeks.
Bye. Thank you, Tom.
Thanks,
Ciao.
Thank you,
Thanks,
Tom.
Tom.
Bye.
Thank you.
Bye.